All right, we're going to talk about increasing, decreasing, and piecewise functions. So increasing, f is increasing on the open interval I if for all a and b in the interval, a is less than b implies that f of a is less than f of b. So as our x's increase, our y's increase. Decreasing, so this first part is all the same. If a is less than b implies that f of a is greater than f of b. So as our y's increase, as our x's increase, our y's decrease. That's decreasing. As x increases, y decreases. Constant, for all a and b, f of a equals f of b. So they're going to remain the same. So here's our graph here. So we're going to look at increasing, decreasing, and constant. And we're going to put these on the open interval. So increasing, that means that we're kind of rising to the right. So as we're increasing here, I notice here's my point, so I kind of put the points in there. So I'm increasing on the interval from 3 to 5. And we only write down our x's, okay? Now I'm decreasing, so I'm going to be decreasing along here and along here. So I'm decreasing from negative infinity to -1 and from 5 to infinity. Okay, so I'm decreasing there on each of those. Now, if I'm constant, I'm going to be constant from -1 to 3. So this value, it's not changing there, it's going to be constant. So now I have my open intervals here of when I'm increasing, decreasing, and constant. When we're talking about increasing and decreasing, relative max and relative mins, so we have a relative max if f of c is greater than f of x for element c is an element of the interval, okay? What that means is it's going to be kind of a higher point, it's going to be a peak. It may not be the greatest peak, but it will be a peak. Relative min, f of c is less than f of x for c is an element of I. So this would be a relative min here. So here's our max, relative max. Here's our relative min. So we want to understand where that's going to be, how we're going to be maximize that. So we're going to look at a little bit of a story problem here. It says 2 nurses drive away from each other at right angles. One drives at 35 miles per hour, the other at 40 miles per hour. Okay, so I'm just going to kind of draw a diagram here. So this is kind of what we're looking at here. So this might be 35, this might be 40 mph. It says express the distance between cars as a function of time, find the domain. So I'm really trying to find this distance here, this hypotenuse. So how far along is this for each piece? So this piece is actually 40 miles per hour, t. And this is going to be 35 t. Well, how do I find my distance here? Well, this is our right triangle, so we can use Pythagorean's theorem. So distance is going to be the square root of 35t squared plus 40t squared. And that's going to give me my distance there. Okay? Now, if I were to find this out, this is going to be 1,225 t squared plus 1,600 t squared. So I end up with 2825 t squared. And if I were to delete this out, this would be 50, or sorry, not delete it out, but square root it out. I'd have 53.15 t. Okay? And you may see its absolute value of t. Okay? So there's my information there. Now, what values of t can I plug in there? Well, what makes sense here? Here it says I could plug in any value of t, right? Positive, negative, 0, it doesn't matter. But that doesn't make much sense if I'm talking about time. Time has to be greater than or equal to 0. So t is greater than or equal to 0. If I was doing it in interval, 0, comma, infinity, I guess technically I should have the bracket there because I could have that. Okay. The next thing we're going to talk about is piecewise functions. So a piecewise function is using different output formulas for different pieces of the domain. So here's an example of a piecewise function. F of x equals x plus 1 for x less than negative 2, and 5 for x's that are greater than or equal to negative 2 but less than or equal to 3. We're going to use the function x squared for x greater than 3. So when I'm looking at these values, I now need to find out where my input is, and I need to put it to the corresponding function. So here I look at negative 5. Well, which one does it fall into? Well, it falls into this one where it's less than negative 2, so I use this top one. Negative 5 plus 1 is negative 4. I now look at 0. 0 is between negative 2 and 3, so I plug it in here. That equals 5. 4 is greater than 3, so I'm going to plug it in here. 4 squared is 16. Now, when we go to graph these spots right here are called my boundaries. So I am going to use my boundaries in this. So I understand that 3 is not part of this. So I'm going to use just a circle in there. I'm not going to have it filled in. It's just going to be a circle to indicate it goes all the way up to 3, but does not equal 3. So if I plug 3 in here, I have 1/3 of 3, which is 1, plus 3 is 4. So at 3, I have a circle here at 4. Now, I need to kind of work backwards. I know that this is a line here. So what I'm going to do is I could plug in a value. I do know that the y-intercept is 3, so I could plug this in here. And I'm going to go from that open circle through that point. So this is just graphing this very first part. Now, I'm going to graph the second part. So I'm going to use this boundary of 3, plug it in here. So when I plug in 3 here, I get negative 3. And it is a filled in dot because this is equal to 3. All right. Now, I have to pick values that are bigger than 3. So I understand that this is a line here. So I pick 4. If I pick 4, I get negative 4. So I'm down here, so I have values that go like this. So this is the graph of this piecewise function. The last thing we're going to talk about is the greatest integer. The greatest integer, this is the symbol for it. The greatest integer is equal to the greatest integer less than or equal to x. So if we're looking at a number line, when we're looking at that number line, what is the value of the integer that's to the left of it, or equal to it? 1, 2, 3, 4, 4.4. So the greatest integer is here, so this is equal to 4. Okay? So it has to be less than or equal to this value. Well, what integer is less than or equal to negative 3.2? Negative 4. Okay? So this is a piecewise function. It takes a different value for different domain pieces. So that's a quick overview of increasing, decreasing, and piecewise functions.